Hello everyone, my name is Maziar Panahi. I am a SparkNLP lead at John Snow Labs. Today's talk is about a SparkNLP, a state-of-the-art natural language understanding in Python. I will have a short introduction about a SparkNLP library. We will go through a SparkNLP missions, and I will walk you through how to get things done by using a SparkNLP. SparkNLP is an open source and forever free natural language processing and understanding library with a permissive Apache license. It is built natively on top of Apache Spark and Spark ML. It was initially released on October 2017. It supports Python, Scala, and Java officially, and it is compatible with a wide range of runtimes and hardware. But these are some of the selected runtimes. Our users are running SparkNLP on Jupyter, Apache Zeppelin, Hortonworks, inside IDEs such as IntelliJ or PyCharm, and so on. SparkNLP has been the most widely used and the most popular NLP library in the industry for the past 3 years. We deliver mission-critical and enterprise-grade NLP used by multiple Fortune 500 companies. SparkNLP comes with a wide range of features to help you in your NLP or NLU projects. Some are classical tasks such as detecting sentence boundaries, tokenization, some of the simple and rule-based text processing like removing stop words, normalization, lemmatization, stemming, and so on. And some are more advanced tasks by using machine learning and deep learning algorithms such as entity recognition, spell checking, multi-class and multi-label text classification, sentiment detection, unsupervised keyword extraction, and almost every state-of-the-art word and sentence embeddings such as BERT, Albert, Electra, ELMO, XLNet, and Universal Sentence Encoder. With over 330 pre-trained models and pipelines in 46 languages, it is a single unified solution for all of your NLP needs. These are some of our selected users using a SparkNLP in their projects, users such as public cloud providers, companies in healthcare domain, and public scientific research. SparkNLP vision since the beginning has been always about providing a state-of-the-art accuracy, high performance, and scalability as one of the only open source libraries with a support for native distribution. When we talk about a state-of-the-art means the best peer-reviewed academic results. For instance, the highest F1 score on CoinNL 2003 dataset for name entity recognition task. We have implemented bidirectional LSTM, CAR CNN, CRF, and word embeddings for transfer learning in our own name entity recognition task. The best F1 score on CoinNL 2003 NER benchmark for a system in production was achieved by using a SparkNLP. For the specific benchmark, we used BERT large case sensitive to train our NER model that has achieved 93.3 F1 on a test dataset and 95.9 on dev dataset. Now, however, we also did our own comparisons. We took an open source NLP library, which is well known, and we tried to compare our NER accuracy with theirs. The point of this comparison was that everything should be working right out of the box. There is no extra steps or manipulation to make something work. All the parameters are default, and as you can see, the SPACY could reach to almost 92% on the dev dataset in NER, while SparkNLP has a very good accuracy from the smaller glove embeddings all the way to BERT large model. The reason we choose to have everything right out of the box is the most open source library don't come with many word embeddings for transfer learning. For instance, SPACY only has 3 pipelines that can provide vectors and 4 models for new and advanced the state-of-the-art transformers. However, SparkNLP comes with 50 word embeddings models right out of the box. Some of the most recent and state-of-the-art language modeling, such as BERT, Albert, Electra, XLNet, ELMO, and other fine-tuned and domain-specific transformers such as BioBERT, Clinical BERT, COVID BERT, and so on. You can choose any of these word embeddings and to train your own naming recognition in SparkNLP. We also have the SparkNLP is one of the very few open source NLP libraries that comes with a built-in multi-class and multi-label text classification. You can use multi-class text classification for problems such as detecting emotions, cyberbullying, detecting fake news, spams, and so on. On the other hand, multi-label text classification is used to detect toxic comments or movie genres or any other real-world problem that each document requires to have more than one label or class. Our classifiers in SparkNLP can use over 90 pre-trained word and sentence embeddings, including a state-of-the-art language agnostic BERT sentence embeddings and Universal Sentence Encoder, which they score very high in STS benchmarks. We have designed and implemented these models in TensorFlow by using the latest approaches, such as bidirectional GRU followed by convolutional neural nets to achieve high accuracy in multi-class and multi-label document classifications. We also managed to accept over 90 word and sentence embeddings with dimensions between 100 all the way to 1024, with up to 100 classes without compromising the accuracy of our final classifiers. SparkNLP is also one of the very few open source NLP libraries that not only offers language detection and identification, but also achieves such a high accuracy in doing so. The models are designed and trained by using TensorFlow Keras. There is no need for any pre-processing, nor any word embeddings are involved. This makes the final model as small as 3 megabyte to 5 megabyte, depending on how many languages they can detect at the same time. And the models were trained over 8 million Wikipedia pages, and they can achieve the accuracy between 97% all the way to 99%. 97% for 32 languages, 99% for 22 languages, as we can see in the slide. Almost none of the top 10 most used NLP libraries comes with a spell checking feature. SparkNLP has one of the best spell checking models in the market. It was initially created to handle bad inputs from OCR results. It can leverage the context of the sentence and document. It preserves and corrects custom patterns, and it will give you the flexibility to incorporate your very own custom patterns. Context spell checker in SparkNLP has broken almost every publicly available benchmark. Now I would like to talk about the performance, the second vision of SparkNLP. We constantly monitoring and profiling the performance of our features in SparkNLP. In early 2020, we improved the speed of training NER by over 60%, and at the same time, we improved the accuracy by 4% in their final F1, when we moved from TensorFlow 112 to 115. Initially, we did it to support Windows, as same as other OSs, but now that is cross-platform, it has a better performance, and it also has and can reach a better and higher accuracy. BERT Embeddings is a member of Transformers family, a new language modeling that generates contextualized embeddings by considering the context of the document in the simplest definition. Transformers are slow by nature, and because they have so many encoders and so many layers before they extract the features or predictions, they all require good GPU to accelerate the speed and the length of the text being fed into their layers highly impact the final performance. Now, that's being said, in our latest release, we managed to improve the memory consumption by 30% and also improve the performance by more than 70% when we implemented the dynamic shapes into our BERT embeddings annotator. If that wasn't enough, we also added 24 new smaller models published on TF Hub by TensorFlow at Google. Models such as Tiny BERT, Mini BERT, Small BERT, and Medium BERT. BERT base model has 12 encoders or 12 layers in a simpler definition. Compared to BERT base model, the Tiny BERT has only 2 layers and it has only 128 dimensions. Tiny BERT is 24 times smaller in terms of size and 28 times faster than BERT base. We care about the size in terms of megabytes because the smaller the model is, the faster it can be downloaded, and almost a few seconds in terms of Tiny BERT. And it also it can be loaded faster into TensorFlow. So in terms of loading Tiny BERT into SparkNLP, it's as almost as it's not a model that it's being downloaded from the internet. It's as seamless as it's an offline, a small model that is going to TensorFlow, which is very impressive. We have done intensive benchmarks on different hardware with different accelerators. Using GPU in SparkNLP is as easy as setting one parameter. And by using GPU, any task that uses TensorFlow as a backend can perform between 40 to 50% faster in both training and prediction or inferencing. However, by using only the newest Intel processors, Cascade Lake on AWS, the performance is close to GPU. And if we compile our own custom TensorFlow optimized for Intel processors, or so-called MKL, the final result in training, for instance, in this benchmark, French NER, was 19% faster than GPU, which GPU is already 45% faster than a generic Intel Xeon CPU, and up to 46% cheaper in overall when you're training for, in this very case, it's just French NER on AWS. Now, regardless of how fast something can be, you either need it to be faster or you have so much data that either it doesn't fit in a single machine anymore, or it will take much longer with that amount of data to finish the task. SparkNLP needs zero code change to scale its pipelines on a Spark cluster. It is the only natively distributed open source NLP library. It takes advantage of Apache Spark execution plan, caching, serialization, or data shuffling. The caveat is that scaling is not linear. You always have a trade-off between single machine and multiple machines trade-offs, such as distributing the data, managing tasks, the network activity, and it also highly depends on the task you are doing. So having 10 machines doesn't necessarily mean that you're gonna get something 10 times faster. Also, the Spark configurations really much matter, and tuning your cluster is also highly advised, meaning knowing your cluster and your data set will help you to take full advantage of distribution and parallelism. As an example here, we would like to look into Recognized Entity DL, which is a pre-trained pipeline. It comes with tasks such as sentence detection, tokenization, word embeddings, and name entity recognition. We took Amazon full reviews. It has 50 million sentences and 255 million tokens. Now, document per second, sentence per second, these are not a good metrics for performance because a sentence could have only 40 tokens or 400 tokens. The real measure is word per second. We have a single node that had 32 gigabytes of memory and 32 cores. And we also used 10 workers in a Spark cluster on AWS by using Databricks, which each executor or each worker had 32 gig memory and 16 cores. So in tokenization tasks, as we can see, the difference between single node and 10 nodes in a cluster, it's the difference between 340,000 tokens or word per second or 7 million words per second. Now, as you can see right here, it wasn't linear. It's way more than 10 times when you compare it. On the other hand, for entity recognition, we reached 38,000 word per second compared to 136,000 word per second when we went to the cluster. It's not a linear 10 times faster, but it did scale over 10 machines. And we did round down numbers, I mean, way down, to be fair. And also we didn't do any extra configuration or extra tuning. And we just treated as like a very novice user that wanted to use a Spark cluster. Now, obviously you could tune the Spark on a single node or even a cluster to achieve even better and higher performance, but we just dealt with it as we didn't know anything about the cluster and how to tune it. And at the BERT embeddings, we did the similar actually benchmark. This time the single node had 64 gigabytes of memory and 32 cores, and the workers were pretty much the same. We set the max sequence length on 128. And the comparison is that on a BERT-based model with 2 layers, we had almost 19,000 words per second. We went to the cluster, we achieved 76,000. And with the BERT Tiny, which is impressively very high number, is 170,000 on a single machine and 480,000 words per second in a cluster. Now, we talked about accuracy, we talked about performance. Now let's see how easy it is to use all this in SparkNLP. So in SparkNLP, you can have Python, Scala, and Java. All the languages have similar APIs without any requirement to change or lose anything. You're not compromising on anything when you're going from one language to another. You can either use the pre-trained pipelines, which they come with a set of features. You can use our pre-trained models to construct your own pipelines, or you can train your own model. In terms of pre-trained pipelines, we have over 90 pre-trained pipelines. They have a full support of 30 languages. It's simple and easy, and they work both online and offline. As you can see, it's just a few lines of code. You start the SparkNLP, and as I told you before, the GPU is super easy. It's just one parameter. If you're on Google Colab, for instance, you select GPU as a runtime and you say GPU true, and you just call the pre-trained pipeline by the name and you just annotate it. And it's that easy. The caveat with the pre-trained pipeline is that they're not flexible. Like this specific pipeline comes with the steaming, spell checking, lemmatizing, tokenizing, NER, embeddings. So if you don't want some of those tasks and you don't want to spend time and computation on something you don't need, or you want to choose a different NER model or different embeddings, we will suggest to use pre-trained models. We have over 250 pre-trained models, more than any library. In fact, the top 10 NLP library in the open source, you can combine all the models they have, they won't reach 250 pre-trained models. We support over 46 languages, same as pre-trained pipelines. They can be used offline and online, so you don't have to have always internet, so you can just download it manually and load it in offline mode. They're flexible and customized, so you can just stack them. As you can see in the slide, you have document assembler, you have tokenization, you choose a model for stop words. It could be anything, any language. You choose a BERT models. We have over 50 word embeddings. You can choose any of them, and you can choose the NER model that goes with that embeddings. Now, the caveat for pre-trained models, however, is that some of the models come together, so you have to match those two models. For instance, here, the embeddings and the NER, they go together because we use them to train them. Now, how easy it is to train your own model. For part of a speech, we provide modules for training and preparing your data set, and you just call the same annotators for document and sentence and tokenization, and you use the perceptron approach, which is a perceptron average algorithm, which is also language agnostic and supports all the languages that you want. And after that, you have your own very specific part of a speech model. How easy it is to train your own NER model, for instance. We accept CoreNL 2003 format. We accept over 50 word embeddings models. It can be trained on CPU, on GPU. It has extended metrics, evaluation, and it has a built-in validation split with metrics that helps you through the training. And it's just a few lines of code, and you can do it entirely in Google Colab. As you can see, there is a test here with the BERT with 2 layers and 768 dimension. In over 16 minutes, you can reach almost 91% F1 accuracy on dev datasets. And because we're using a smaller model of the BERT, you can achieve this entirely on a Google Colab with only 12 GB of memory. Now, in terms of classifiers, just as an example, you have you can support up to 100 classes. You have 90 word or sentence embeddings, same as NER. It can be on CPU or GPU. It has extended metrics and evaluation during the training to help you go through this training and stop it at the time that it's almost reached the accuracy that you desire. So the field of NLP is one of the most dynamic and rapidly growing fields in the AI and computer science. We have had 73 releases in the past 3 years, which means 1 release every 2 weeks to keep adapting to the new trends in NLP and NLU. We have an active community on Slack and GitHub, which I would like to thank them all. SparkNLP has over 330 pre-trained models and pipelines supporting 46 languages. Many features only are available in SparkNLP. The wide range of out-of-the-box functionalities in SparkNLP makes it a unified solution for all of your NLP needs. Thank you for your time, and I hope you enjoyed this talk. I appreciate it.